Hey there, today we're going to talk about exponent rules. We're going to take a look at this first one, a to the m power times a to the n. When you have the same base, a, then what you do is you just add the two exponents, like so. So like these examples, 3 to the 4th times 3 to the 5th, the base stays the same, the 3. 4 plus 5 is equal to 3 to the 9th. Okay? The x's stay the same in the next one. X, 7 plus 9 is what we'll do with the exponents. We'll add them together. We get x to the 16th. B will stay the same. It's the base down here. Add the two exponents, a plus c. Because a and c are both variables and they're not alike, we can't add them. So to multiply, terms that have the same base, you can add the exponents. This next one, the division is very similar to the addition or the multiply one, except in this one, you take the top exponent and subtract the bottom exponent from it. Okay? So here we're going to do 7 minus 2. And you get 4 to the 5th. Here we're going to do 17 minus 21. And you get x to the negative 4. Okay? So to divide terms that have the same base, you can subtract exponents. This next one here, a to the m to the n power, is what we call a power to a power. And the way we do that, we leave the base the same. You do m times n. So here you do 3, 4 times 5, that would be 20. So 3 to the 20 power. Negative 2, and I believe that's a 5. I'm not sure about that. Whatever it is on your paper, it's going to be 5. I'm going to treat it as if it is a 5. So 5 times negative 2 is negative 10. 7 times 3, x stays the same, and you get 7 times 3, which is 21. Okay? To raise a power to another power, you multiply the exponents. Okay? If you have a negative exponent, you just pretty much do the reciprocal of the term. So you can put it over 1, or under 1, I'm sorry, a to the m power. And then you just make the exponent positive. So like 10, you're going to move it down to the bottom. Instead of a negative 5, when you move it down, you change it to a positive 5. 5, move it down, it becomes 1 over 5. The power of 5 is 1, so you don't really have to write that because 5 to the first is 5. The x to the negative 7, you put it under 1, and it stays x to the 7 power. So negative exponents mean to do the reciprocal and make exponent these last two rules, I put them on a separate page, and the reason being is because we're going to use this roots table down here to be able to look at that. Whenever you're dealing with a fractional exponent, the top is what we like to call the exponent, and the bottom is what we like to call the root. So the ones over here where it's just a to the 1 over n, it just means that your exponent is 1, so you don't really have to deal with that. So basically what you're doing is the nth root of a to the first power. Okay, so when you're doing 81 to the 1/2 power, you're doing the second root, or the square root, of 81, which is 9. 16 to the 1/4, you're doing the fourth root of 16 to the first power. And this chart down here, you go here where the fourth is, 16 is right here, and the root is 2. So the answer is 2. And I believe that is x to the 1/5, so you would be doing the 5th root of x. So rational fraction exponents mean take the root of the base. Okay, for fractional exponents, the numerator, just like we said over there, it was the exponent. The denominator is the root. Okay, so when you do a to the power of m divided by n, you're doing the nth root of a to the m power. And this power, this exponent right here, it doesn't matter if it's outside the square root or if it's inside attached to the a. And I'll show you a couple with the examples. Like here we got 3 halves. So we're doing the square root of 81 to the 3rd power. And what I really like to think of it is you find the root first, so like square. And I'll do this example in purple. So I'm going to start here with my square. 81 is not there, but 81 would go with 9. Okay, and then I do 9 cubed, and 9 cubed would be 729. So I would start here and then finish where the exponent of the numerator is. So this is, oh, I'm sorry, this is 729. Okay, the next one we're doing the 4th root of 16 to the 3rd power. And this one's a little nicer because the 4th root, 16, it started here, get you here, and then we want the 3rd power, so we go to the 3rd, which is 8. So this answer is 8. In 2/5, we get the 5th root of x squared. And so I kind of showed you from here to here to here. It doesn't matter if the exponent is inside or outside, it's going to still have the same quality. This roots table, you can make this as large as you want or extend it as far down as you want. A good number to go to would probably be 10, but I know the numbers out this way, if you go to 10, are going to be super huge, so you may not want to get the whole thing. So you just get as much as you can fit in there. What I would suggest to you to do is put exponent rules and roots table and 2, you're factoring flip chart. Okay, remember, you can use your factoring flip chart on any test, so this would be a great tool for you to have as you come up on tests. All right, thank you. That's it for the exponential rules, and I'll see you next time.